Welcome back to Workplace 30. We're continuing section 7.2, which is the cosine law, and we're starting today with word problems. So we'll have a look at example 1. Here, from a lighthouse, one boat is observed 8.3 kilometers away, another is observed 12.5 kilometers away. The degree, or the angle, between the two lines of sight to the boats is 68 degrees. So how far apart are they? So we're going to use our cosine law. And remember that when you use the cosine law, you need the angle and the side length opposite it on opposite sides of the cos equation. So we'll have a squared equals b squared plus c squared minus 2bc cos a. Here our angle A is 68 degrees and A is what we're looking for. So it doesn't really matter what B and C are, but here they have them labeled for us. B is 8.3, square that, C is 12.5, square that, and then subtract the two multiplied together. So we're going to start by squaring our 8.3 and our 12.5 and adding them together to get 225.14 minus 2 times 12.5 times 8.3 is 207.5 cos 68. Now since we're following BEDMAS, we still have to multiply first, so we need to solve this by multiplication. So we get 225.14 minus 207.68 and cos 68. So this is 77.73. We subtract the two, so we get a squared. So a squared is 147.41. Square root both sides of this to get our final answer of a equals 12.14 kilometers. Then let's look to example 2. Here we have Zoe who's tiling a room in her new home. The room is irregularly shaped and the floor corners do not form 90-degree angles. So it's an oblique triangle. Zoe must cut the floor tile to fit correctly in the corners, so she needs to know the angles. She measures the room to be 20, 19, and 18 centimeters. And sorry, this is not the room. This is a piece of tile that needs to fit there. Otherwise, it would be a room in the school for ants. Yeah. So first we're going to use our cosine law to figure out any one of these angles. It does not matter which one you start with. Let's just start with this one. So let's title this A, B, and C, and we'll have a squared equals b squared plus c squared minus 2bc cos A, where we're looking for angle A and we're given side length A. So we get 20 squared equals 19 squared plus 18 squared minus 2 times 19 times 18 cos A. So here we can right away get rid of the 19 squared and 18 squared by subtracting them to the other side. And we end up with negative 285, which then when we multiply negative 2 times 19 times 18, we get negative 684 cos A. Divide both sides by negative 684 to get a small decimal number, which is 0.417. Then we need to get rid of our cos to just get our angle. So we hit second function, cos, which is our inverse, to get the measure of angle A equals 65.38 degrees. Now we can do the same thing for angle B. Go ahead and try that now. So when you finish doing this, you should get that the measure of angle B equals 60 degrees. We can find then the measure of angle C because 180 degrees minus, oops, that's a funny 65, minus 60 is going to equal 55 degrees because all three angles in a triangle need to add up to 180. We're going to move then to mental math and estimation. So here we have the following side lengths. We want to determine which angle will be the largest and which will be the smallest. Remember that the largest angle measure is always across from the largest side. The smallest angle measure is always across from the smallest side. So the largest angle is going to be angle C, and the smallest angle is going to be angle A. All right, so then we're going to do the discuss the ideas, which is on land surveys. So here we have, there's these 3 points and a big, I think it's a big bush in the middle of it. What measures? So what measurements would the surveyor need to calculate the distance between B and C? So to use our cosine law, we either need all 3 side lengths or we need 2 side lengths and an angle measure. So if we had side length C and side length B and the angle measure of A, we could also determine length BC using the cosine law. So let's say that they actually find AC to be 322.5, angle A is 79, and side length C is 247.4. So let's use the cosine law to figure out side length BC. So you'll get all these big numbers and you should find that A equals 367.1 meters. So then we're going to move on to question 2. So if the surveyor measures AD and angle DAC as shown in the diagram below, then he moves to point D and measures distance CD as shown. Has he measured the angle correctly? Explain your reasoning. So is this angle here, angle A, is this correct? This angle. So please use the cosine law to figure that out. So you make sure you got it set it up like I do here in the problem. Then we've got angle A, you'll find is equal to approximately 30 degrees. So is that what he found? No, he found 31. And even though it's close, in surveying, you need to be very, very precise. So this would actually change his measurements by quite a bit. So then the last part, here we have a right triangle. We want to know if the cosine law still works for this right triangle. So yes, this does actually work for a right triangle, and here's the proof of how. So if we take the cosine law and we set it up according to this triangle where C is the angle that we're considering, then we need to plug it in 90 for angle C. Now cos of 90 actually equals 0. So when we sub in 0 and multiply it by 2ab, the whole thing turns to 0. So you end up with c squared equals a squared plus b squared, which you'll note is the Pythagorean theorem. All that you have left is an assignment on page 266, number 1 to 7, and there is also a puzzle to try. Go ahead and give it a try.